Hello everyone, hope you're having a good day. Today we're looking at section 10.2, solving square root equations. In the past we have solved equations that have a square involved, so that are like x squared equals 16, right? We've square rooted both sides and then we found that this is plus or minus 4. But today they're going to give us some type of equation that's the square root, and we're going to have to figure out how to solve for x in this situation. We know that the square root of something is the opposite of something squared, or those are inverses, just like plus and minus are inverses, or similar to how plus and minus are inverses. So we are familiar with what we're looking at today, but just totally focusing on solving these equations. So students will be able to solve equations involving square roots. Students will be able to check for extraneous solutions, and that is a new term for today. It's not too bad. So first thing we're looking to do, well, our lesson today is going to be examples. So there's one term that we'll look at the end, the extraneous solutions, but other than that, then I'm going through some examples. Our first step when we're trying to solve these equations that involve square roots is to get the square root all by itself, to get the square root on a side all alone. The way we do that here, so I guess I'll write it down so we have the steps. Get square root alone. So that would give us square root of x equals, we subtract 5 from each side, equals 8. Then after, and now it might take 2 or 3 steps to get the square root alone. In this case, it's only one step, but there might be times where it takes a couple steps. After we get the square root alone, our next step is to square both sides. So in order to get rid of the square root, we are going to square both sides. Now our last step is to simplify. So we would have x equals 64. If we look for just a second at this, when we square it, I mean, think back to chapter, oh man, it was the beginning of, not the beginning, it's the middle of Algebra 1B. But we talked about we can rewrite a square root like this. Right, our square root is just x to the 1/2. And then with our power of a power rule, we can multiply these. So this would just be x to the 1, so that just gives us x. So that is why we can undo this square root here by squaring both sides. So there's the logic and math behind that. Let's look at this other example. First, we need to get the square root alone. So that means we have a positive 3. We need to subtract 3. So we have negative square root of x equals negative 3. Now we have the negative in front, so we need to divide by, technically it's negative 1, so we'll divide each side by negative 1. So square root of x equals 3. Now we need to square both sides and simplify. Whoops. 3 squared gives me 9. So in this case, I said that it might take a couple steps to get x by itself. In this case, it took 2 steps, right? Here's the first and the second step to get rid of that negative. So there are times, like I said, where it could take 3 steps or something like that, or it could take 4 steps. We just have to be ready for any of that. All right, here's another example. Notice this time we have the square root, or underneath the square root we have an x and that plus 2. So we'll see how that changes things. Our first step will be to get the square root by itself. So we need to subtract 3 from each side. Now we need to divide by 4. Now that we have the square root all by itself on that side, we can square both sides. Even though there's something in the square root, we still can square both sides. And now in this case, I mean, our first step of get the square root alone took 2 or 3 steps. Squaring both sides will typically take 1 step. But now we're simplifying. We have x plus 2 equals 16. Well, to get x totally by itself and solve for x, we need to subtract 2 from each side, and we would get x equals 14. So our simplifying took 2 steps. But if we have a square root with x plus whatever inside, no big deal. We still can square both sides and get rid of that square root. One more type of problem that we'll see, then we'll get to our term and one more example. So we're in the home stretch here. If we have something where we have both sides that are square rooted, right? We don't have like any plus 3 out here or anything messing with it like that, just we have completely both sides, or both sides are completely square rooted. We are allowed to just square both sides, just like we did earlier, to get rid of that square root, because as long as we stay consistent, whatever we do to one side, we do to the other, then we can do whatever we want, and the value of these equations stays the same. So our first step would be to look to square both sides. And then when we square both sides, since everything's under the square root, that gets rid of our square roots. And now we can just solve for x. So pretty straightforward, almost easier if both sides are totally square rooted, but it's a form that we're not used to seeing. We're not used to just bringing in the squared kind of out of nowhere. Now our turn, extraneous solutions. Notice extraneous has the word extra inside of it. That's going to be kind of important here in a second. Squaring each side of an equation can sometimes introduce a solution that is not a solution of the original equation. This solution is called an extraneous solution. Be sure to always... Oh my God. I haven't finished my coffee yet, that's why. Be sure to always substitute your solutions into the original equation to check for extraneous solutions. So here's an example. We have x equals the square root of x. Now, if we were solving for this with the rules that we've talked about, we have the square root on a side all by itself. So it's already alone. Now we would square each side. And now we have an x squared on this side and we have an x over here. So we know we can't combine those. But what we would look to do is get everything over to the same side so that we can set this equal to 0 and either factor or use our quadratic formula or something like that to solve. So we would have x squared minus x minus 6 equals 0. We could factor this out to minus 3 plus 2. So we find, and there will be times where we find that x equals 2 different numbers. Now we have to take both of these numbers and plug them back into our original equation to make sure they work, make sure they make sense. Now, if we plug, let's start with x equals 3. So 3 equals the square root of 3 plus 6. 3 equals root 9. Yep, this checks out. Now let's look at x equals negative 2. Negative 2 equals square root of negative 2 plus 6. Negative 2 equals square root of 4. Well, is there any way we have a negative 2 over here? Is there any way we can get a negative out of this square root? I mean, we know that the square root of 4 is 2. So we know that negative 2 equals, or negative 2 does not equal positive 2. But when we were going through this, we should kind of have suspicions, right? Because if we're saying that a negative number is going to come out of this square root, unless there's a negative sign in front of it, then we're kind of in trouble. But we are able to simplify this down to -2. We're saying -2 equals 2. Well, that's not true. So -2 is not a solution. So this is what I would expect to see, like in your homework, that you get 2 solutions, you check them both, and then somewhere down towards the bottom in your final answer, you would say, x equals 3, or you would cross out -2, or something like that, showing you that you checked both and you understand that one of them did not work, so that is not a part of your answer. All right, that's all that we have for today. So hopefully those examples were helpful and something that we're kind of familiar. I know that we haven't been working on squaring both sides, but we have done a lot with square rooting both sides. So this is not something that's way off in left field, kind of coming out of nowhere. Also checking our answers, right? We've done different things, maybe not to always check our answers, but to plug our numbers back in to get a y value, or done other things to plug numbers into equations. So just looking at some of the skills we already have in a little bit of a different context, but shouldn't be too bad. If you have any questions or need help with the homework or anything like that, make sure you let me know. Otherwise, I will